So I'm going to be talking about iOS development, so writing apps for these things and for iPads. And I've got, I think, probably more slides than time, so I want to know which ones to skip. So my assumption is that you guys are mostly enterprise-y people. Raise your hand if you're an enterprise Java person. Raise your hand if you're an enterprise non-Java person. Cool. Raise your hand if you are a client-side person. Cool. Raise your hand if you are a .NET person. Raise your hand if you use a relational database. If you use a non-relational database. If you use REST services. SOAP services. Cool. I'm sorry to those of you who are using SOAP services. But I apologize in advance. Cool. So me, meanwhile, I'm Patrick Linsky. That's me. Skiing this winter is awesome. I'm also at a startup called Versely. We build collaboration software, Java server backend, C#, Objective-C, JavaScript clients on the front end. So I see a bunch of different pieces of the technology stack. I have done a lot of enterprise Java stuff in the past with object relational mapping frameworks and app servers. I used to work at BEA, then Oracle, and I still do a bunch of stuff on our server, but I'm actually primarily responsible for some of our client stuff at Versely. And I've written a number of different iPhone apps, either for myself or helping out my friends and whatnot. So I'm going to start off with a quick little Objective-C primer. Another question, who here has written Objective-C code before? Okay, cool. So Objective-C is basically, it's created in 1984, something like that, 1983, and as a way to bring objects to C. So it predates C++ and goes in a different direction than C++ really. And so it's straight up like, how do you take a Smalltalk-like environment and bring that to C? A Smalltalk-esque object language and bring that to C while preserving full compatibility with C. So that means it's a little bit weird. You deal with messages, not methods. So everything lives inside of these square brackets. When you're invoking a method on something, the thing on the left-hand side is the target, and then the thing on the right side is the message you want to send to that object. And everything's kind of infix notation, which tends to be a little bit weird because it means that if I want to create a new NS array, so interesting little bit of history, right? Objective-C was created in 1984 or so. You'll see all these things that say NS as prefixes because there's no namespaces in Objective-C. So everyone just kind of namespaces their libraries with some sort of a prefix. This stands for next step. And in fact, everything extends NS object. So that didn't happen until much later. So Apple got involved, or Next Step got involved with Objective-C much later. And before that, there was kind of a lot of the libraries you see, Objective-C has become very intertwined with Next Step. And there's a lot of of language to library coupling that exists there. So that's what that little NS thing is. This is how you create a new list. And what we're seeing here, one thing is that we have this infix notation. We're allocating memory, and then we're calling the constructor. A lot of this is convention-based. Objective-C is a very convention-based language versus a rules-based language. So this constructor pattern, you can also do NSArray new, but kind of no one does that. People tend to use the alloc init pattern. And if you do call new, all that is doing is it's a language syntax for alloc and then the default init. So you end up with a lot of these sorts of convention things where init's just a method like any other method that you're invoking on the object that was allocated with alloc. And we'll get back to memory management in more detail later. But so this is essentially a static method invocation followed by a instance method invocation. And one annoying thing, the braces, you get used to the braces real quick, but one of the annoying things is when you decide you need to do another dot something else over here, that means you need to go all the way back to the beginning over here and add a square brace at the beginning of the line when you're chaining methods together. The Xcode, which is kind of the predominant IDE for Objective-C development, does a lot of this automatically for you, but it is something to bear in mind. And one last thing on this slide is types are optional. So ID is the type of anything, and you can send any message to ID. So if to the extent that you provide type information, you get a certain level of static type analysis. To the extent that you don't get it. Message arguments, pretty straightforward. String with format. Here we're invoking a static method that has an argument, this format string we're passing in. And arguments get basically inlined into the method name. So when you're passing a message, that the thing that would be in Java, string open parens format, and then you have a parameter called format. In Objective-C, you actually just have this method name that becomes very, very long. So it ends up being a pretty verbose syntax, and you actually don't have type overloading. So instead of using type overloading, you just have all these different methods that would say string with format, string with integer, et cetera, where the message name itself, the selector name itself, is defining the full specification of the invocation, which is at first a little bit jarring because you end up with these very long and descriptive method names, but it actually you get used to it very fast, and it's very readable. It means that your code, there's a lot less ambiguity, a lot less consulting the documents and the parameter lists and whatnot when you're writing Objective-C code compared to writing kind of normal curly brace languages. There are a couple legacy C issues. You write your interface declarations in header files, and then your implementation in a separate file, and there's a one-pass compilation. So because it's faster, right? These days we don't really care about the extra speed improvement of a one-pass compilation at compile time. I'd rather be able to not have to forward declare things. So you do have to do a couple of those sorts of things that the C world foists upon us. But just kind of welcome back. And there's also, you see a lot of these directives. We're going to dive into some actual language stuff after this slide, and you'll see a bunch of these signs. And they're basically there's the and there's also caret that gets used a little bit. We'll see them later on with blocks that get used for Objective-C things, because is a reserved character in C that is not used. So the Objective-C kind of uses that as now we're in Objective-C land escape. So when you write a string, you can do @foo. That creates an NS string rather than a character buffer. When you see @property and @synthesize and things like that, these are all different things that turn into compiler, essentially preprocessor directives that the Objective-C compiler uses to do a bunch of syntactic sugar and things like that. So they're part of the language, even though they kind of look like they're an annotation or something like that. So architecture-wise, the kind of enterprisey architecture is you've got a lot of people talking to over the network to a bunch of servers, kind of to your first tier of servers here, and then those servers in turn talk to some EJBs and some business logic and things like that. So the presentation tier, oops, sorry about that. There's a very incredibly subtle highlighting here. Sorry about that. So the presentation tier of your application deals with a lot of inbound requests from a lot of different people, and then delegates that work on to like a business tier that does a bunch of stuff around how do we want our controllers to be written, and what do we want all of the business logic to do and whatnot, and then that delegates on to some backends or some enterprise stores or other systems or what have you at the integration level. Maybe using something like JDBC and SQL or an object relational mapper or different things like that. In the iOS world, we have a pretty similar picture. So on the back end, we have entities and whatever we want to be using for our store. We have there's SQLite is the kind of the de facto database that people use on devices. So you can talk SQL to it, or you can use the object relational mapping framework that comes with Objective-C core data or comes with Xcode core data to talk kind of objects to your store. Both of them are have the same trade-offs you do in the rest of the world. And then logic ends up you have this in front of your business logic tier. You have this thing called a view controller, which is your controller on top of some views and some different widgets that you end up dropping into your views. And then one of the really interesting differences is that you're talking to one person rather than talking to a lot of people. There's only one user of the application. Right now I'm using the Keynote app for the iPhone to control my slides. And there's only one person who's using it, right? I only have to worry about a single user. And that changes everything. It changes how you do a lot of development. A lot of things are the same, but then you get a very different environment because you're only talking to a single user when you're writing your application, essentially. And I'll just, since you can't see those animations anyway, let's just go away from them. So we end up with the standard kind of MVC pattern. Right, that's the majority of iPhone apps are written as MVC apps, where you have a model, a view, controller. The models are exactly what you're familiar with in other environments. The views have some nice characteristics to them. So you have this view tree where we have a root level view, which is like the app, the container that everything's inside of, and then we have a bunch of sibling views, which unlike some presentation frameworks, can really easily overlap. The assumption is kind of overlapping. So unlike HTML or something like that, where making things lie on top of each other becomes difficult, the iOS view tier is the kind of the tree you deal with in memory and the visual representation of it are pretty separate representations. Including here we have in this case we have an image view in the background here, and then we have a control. Maybe we're doing something for watching a slideshow, so we have play and pause as translucent kind of items that can sit on top of the screen. Really easy to do. In other frameworks, you see all these. In the C# world, you have what's it called? Drawing a blank on the name. In Java world we have grid bag layout, and in C# there's an analog whose name is totally escaping me right now. In any event, we have all these different presentation things for kind of what the best way of writing, of creating some layout on a page might be. In HTML we end up with all these tables and divs and et cetera, et cetera. None of that exists in Objective-C. For the most part, everything we have is we just have springs and struts. It's kind of the best UI modeling framework I've ever seen. In fact, I should restate that. It's the best UI modeling framework I've ever seen for kind of building a layout. Because instead of having to deal with, okay, I need a grid and I need this grid to be 3 columns wide and 7 deep, and where do I want my extra space to live, et cetera, you have these springs and struts where a spring is these dotted things here, and they can take up an arbitrary amount of space. And so in this case right here, we want our play control to be towards the bottom. So there's a strut here saying it's going to be this far from the bottom, and then springs connecting it to the rest of the UI. And then those springs and struts, you can see another one in the background here, defining the size of the minimum size of our, or actually the absolute size of this control. Basically, those springs and struts then just get added up by the presentation code to figure out where everything needs to lie on the final presented output. And this turns into the absolute easiest way of building a multi-sized, rotatable, et cetera, presentation framework I've ever seen. It's amazingly easy to create something where when you take your phone and you rotate it, the right thing happens. Much easier than it is if you're dealing with kind of like resizing HTML to deal with different display sizes or things like that. So they've done a really knockout job of dealing with that. And one thing I just don't understand is why that hasn't been stolen. Like why no one else is just, because this has been around forever. And when I wanted to take my iPhone app and scale it up to the iPad, I don't have to change this at all. right? My presentation that the layout I've created with springs and struts as kind of the only primitive for really positioning just works as I scale it up to different size screens. And I've seen this happen on a number of different applications where you think it's going to work out well and whatnot, but you're like, oh, let's see what happens when we move to the iPad. And for the most part, it's only where you're like, well, I really want this to be 3 pixels over that you start to get burned when you start doing absolute layout stuff. And as long as you're working in springs and struts, everything is just really, really easy to build and deliver. Our strut length is, all that's happening here is the spring's like, okay, now I need to be a longer spring. Really easy. And so before I move on from that, actually, these screenshots, or these mock-ups, I guess, are essentially mocks of what you end up seeing when you're using the Xcode has this interface builder tool built into it that does all this work for you. And so you can do it all drag and drop wise, or you can do it via code. So the kind of both styles of code-oriented or drag and drop wise oriented presentation layouts are totally legitimate and available for use. I tend to do most of my iOS coding at the drag and drop level for the view definitions, but sometimes you need to dive in and do something that's going to be a little bit more custom or vary depending on different conditions and whatnot, and it's easier to do in code, and that's a legitimate thing to do. There's actually some cool tools out there that will take the interface builder output and turn that into Objective-C code so that you can kind of get started with this and then switch yourself over into a code-oriented approach if you need to. So syntax-wise, like I said before, this is Java syntax up here. It's also pretty much C# syntax modulo the case that we're using here. The Objective-C syntax is to do this with braces. So when we're writing our controller code, you basically end up doing things where you're looking at widths and heights and things like that, and then you're configuring what you want your view absolute size to be by just sending these messages. Here we're sending the message set width : height to the view object, and that actually is the full message name. So set width : height is the full name of the thing. These aren't positional parameters. They're kind of infixed arguments to the method. And then we have some syntactic sugar as well. So view brace width can turn into view dot width. Kind of setter getter pairs have setter getter notations using the dot operator. Even though these things are, from a C standpoint, pointers, we can use the dot notation as a way of accessing the member variables. Another big difference in the controller world of things is in Java, we do a lot of listener-based things, where we want to get a listener when something happens, right? In the Objective-C world, we do more of an action-oriented approach, where I want to register a selector. So this do something selector is a message that is going to be passed to self. So when the button touch up inside event is fired, the button will send self the do something selector. And you do that rather than creating all these little listeners and stuff like that. Turns into a very loosely coupled approach to UI development, where again, because like I said earlier, a selector, a target any object you have in Objective-C can receive any message. So you don't even necessarily need to know whether or not do something is actually implemented against the object you're sending this to. You won't get a crash in your application when that happens. If a target does not actually support this selector, then the runtime will just not send the message to it. The message will not get delivered. So there's no exception that happens or something like that. So it becomes a very easy way to say, here's my, all I really need to do is whenever someone clicks this button, I want to invoke this. Really easy to do that. You don't need to create an inner class. You don't need to create any kind of additional language ceremony to do so. You just say, here's the selector I want you to invoke. Really cool that selectors are first class parts of the language. It means that you can essentially pass around function pointers really easily. Which is something that I sorely miss in the Java world and actually enjoy about C# as well. So notifications, I kind of touched on them there in terms of actions. Well, the big brother of a of just having these little actions that you can register selectors for is the notification center. So we can actually register with the notification center. We look up the default notification center here, and then say, whenever, so in this case here, we're saying, right now I want to just notify whoever that a person was deleted. So the way you tend to build your domain model, the way you link up your domain model to your controllers is that the domain model goes and says, okay, something's just been deleted, right? I'm going to delete this person, and then the controller tier and other parts of the view and whatnot receive notification of this by registering. They add themselves as an observer. So we've registered the person did delete : selector on the current object to receive all notifications whenever a person is deleted. So what that lets us do is it makes it really easy to then implement that method that this selector is pointing to do whatever work we need to do to remove the person from a list or what have you. So you end up with these kind of controller elements in your presentation tier that are not directly being communicated with by your domain model and whatnot, but instead there's this event and notification-based framework sitting on top of them that lets us do very efficient, very easy, very readable, loosely coupled event notifications as things happen in the model. So building on that, we use delegates. So controller objects, if I'm looking at a list of all my contacts on my phone, then that's backed by a list view. The thing I'm looking at there is a list view. Behind that, there's a list view delegate that is responsible for knowing how many items we have in the list, what a given item is for a given index, and then optionally some information around letting people select the current element and interact with a list. So what we do with delegates is instead of implementing an interface, we're just we create this delegate implementation where we're essentially just doing a mix-in to our class, which then when the view is linked up to this delegate, it then interrogates it to find out what it can do, discovers that it may or may not support selection based on whether or not it can respond to a given selector. And then the list is actually responsible for because this lets us directly link up our code without having to go and create some subclass or some interfaces and whatnot. And what that lets us do is it's really, really easy to create a loosely coupled controller that responds to all the events we have defined in our object model, and you don't really need to worry about routing all these different events to all the different parts of your application because the notification center just takes care of that for you. So standard MVC stuff is pretty cool, but where Objective-C starts to get really interesting is especially iOS development is really interesting is when we start looking at the differences in concurrency approaches and what you can do as a programmer without, now that you don't need to worry about or we think about concurrency in a very different way on the phone, both in terms of the language features we have and also in terms of the use cases. And it's pretty neat stuff compared to the enterprise development world. So the model for concurrency in the enterprise world is I have a bunch of jobs I need to get done, right? I have a factory line of requests coming in, and they just keep on coming, and I need to deal with these requests as quickly as I possibly can. And so we generally have this model where we have a bunch of stuff coming in, and we want to just load up our cores, right? And that works great. But then in reality, we end up having this big mess of operations. This only works if we've done a really good job of pipelining things on the way in, which servlets and whatnot do for us. But then if we have a bit more of an ad hoc world in the Java enterprise world, we need to figure out how do we convert these arbitrary little blobs of work into something we can pipeline onto CPUs in an efficient manner. So in the Java world, what we end up doing is locking. Right, we end up having to do some level of locking. Maybe we can do some lock-free stuff with some of the concurrent utilities and stuff like that. But there's still at some level, there's often at least an atomic lock that's happening where there's a shared data structure that everything's writing to, and it kind of becomes a bit of a pain. In the iOS world, the picture is different because again, we're dealing with a single person interacting with something, so we don't need to worry about the lock so much. there's a single user interacting with the data. So as long as our data is being dealt with in an appropriate, as long as we aren't introducing a bunch of threads that are talking to things, we don't need to worry so much about concurrency. Instead, we do things with threading and with delaying operations and with this thing called Grand Central Dispatch. So Grand Central Dispatch essentially lets us take a bunch of different threads and take all the work we need to perform against those different threads and then dump all of the actual work into a dispatch queue that then deals with all of those synchronization issues for us. So here we have an example where we have some block of data, and then the naive approach to the world is I need to load some data and I want to show it. Right, so I'm going to launch an application. I'm going to show data, and this is one of the things you see in a lot of naively written iOS applications. When it loads, or when the user clicks on next or something like that, or clicks on some action, the UI freezes, and that's because they're doing work right here on the UI thread. So when you're writing Objective-C code for the iOS for the iPhone, the actions that happen when you click on a button will happen on the presentation thread, unless you do work to make that happen otherwise. So a better way to do this is to say, okay, I have a block of data and I need to process it. So I'm going to just ask for that to be performed on a different thread. So I just want it to be performed in the background, and the iPhone will take care of finding a thread and dealing with making that happen. And then we have a process data implementation that then, because we're now doing this work on a different thread, those of you who've done C# or WPF development and things like that, we then need to route our selector back to the main thread for presentation purposes. So presentation, all of the presentation logic that happens that's also a shared data structure that has to be happening on the main thread. So we can do our data processing takes a long time in the background, and then we need to say to the main thread, hey, now I want you to display something. Here's the result, and then the display will catch that and do whatever it needs to get that data shown on screen. So that's pretty easy. But it's also not that, just starting up all these background things and whatnot, that's only useful for if we need to invoke something that's kind of a blind operation that's just going to happen in the background. So another thing we can do is delay. So another kind of approach to dealing with UI concurrency issues on the phone is I just want to do something a little bit later. Rather than blocking, for example, in the case of writing a slide presentation or like a slideshow application where you want to have a bunch of pictures that you're kind of playing through, where you hit play versus pause. Well, after a few seconds, we want those controls to disappear, right? So if I want to start watching my movie or see the next slide or something like that, I want a control to show up for a second and then I want it to disappear. I don't want to spin, right? If I just sit there and put a thread.sleep into my code, then I'm going to end up blocking the UI again, which is bad. So instead, we can perform a selector after some delay. So we can say, hey, just basically ask the controller object to just wait 3 seconds before actually performing a given operation. And then that's really easy to also back out of. So if if the user touches the screen again or something like that, we want to keep the controls on the screen. We can just cancel some request, and the underlying system will take care of tracking down the requests that we had already requested to be performed here, and then just cancel all of them. But this again is only as we end up still seeing code where sometimes we need to do some block, right? Where we don't want the user to interact with code while something's going on. So we can just do something where we pop up a busy indicator and then continue on with work. This is a pattern you'll see people do, and it's a bug. Because when the controller controller code is being executed, we're executing that within a run loop. So in the kind of event queue pumping mechanism that the iPhone uses is controller code executes, then all the views get updated, then there's idle for however long, then there's some touch event that pulls us out of idle and back into action, and then that turns into a message being sent to the controller. So as this loop's happening, if look in this example here, if we show a busy indicator and then process data, there's going to be a pause. This is never going to happen because the showing of the busy indicator is going to this line of code right here will happen up in the controller, and by the time that we get to the update view, this process data will have fully happened. Will actually, this line of code happens during the controller phase, and then the controller phase doesn't exit until this process data has happened. So we can, again, even though we think we're writing code that will show a nice little friendly busy indicator, because we're doing it during a run loop, and because we're then performing this operation, this long operation during the run loop, we end up kind of showing, spinning freezing the UI for the user. So what the iPhone does for that is, that's one of those places where tossing something into the background or just requesting something to be done a little bit later actually works well. So the pattern that you see people using is kind of neat. That whole after delay thing, well, you can ask an operation to be performed after 0 seconds worth of delay. And this doesn't happen now. It happens, essentially what this ends up doing is it happens the next time that the run loop is being executed. So it's essentially just putting another operation onto the event queue so that instead, with this code, we will actually get to show our busy indicator right here. We ask for the show to happen, and then that show will happen, and then as soon as we get back to idle, there's going to be an event in the queue saying, hey, there's this thing that has to happen immediately. So that'll kick off another run loop, which will then be the thing that actually performs the data lookup. And kind of taking this whole delaying model kind of one step further is Grand Central Dispatch. So Grand Central Dispatch is a means for taking a whole bunch of little pieces of work that we want to perform and performing them in a linear fashion without having to do any locking. So if we want to take this stuff and put it onto multiple cores, we can use a bunch of threads, right? But threads are expensive and not as nice as a queuing model for all sorts of reasons. One is Grand Central Dispatch allows for things like prioritization of work and automatic configuration of where work should get written to and whatnot. So this lets us do basically take a block of code. So a block is essentially the Objective-C answer to a closure where we can take some function and there we go. And turn this into a block with instead of using a function pointer, we use this hat symbol to identify that we want this to be a block that can be executed and that can capture its containing environment. So an example here is we have a trivial block that where we can invoke on this block, passing in 1 and 2, x and y, that turns into x divided by y. So not surprisingly, we get 1/2 in that case. And then we can be a little bit more fancy where we take the block and close over some externally defined variable. So in this case, again, we're doing x by y, but we've defined our denominator and we're passing in the numerator over here. And that works. And then we can get even more fancy and create a block factory. So you'll see this pattern a fair bit in code that uses Grand Central Dispatch, where we can create a method that returns a block. And this is a block that knows how to divide by y. So it's exactly the same block as we saw in the last one, except now instead of having a statically defined numerator, we're passing in a numerator to the factory method, and then getting our divide by y code written here, and then we've essentially defined this as the block called divide by 2, asking for a factory method that can divide by y, where y is 2, and we're in good shape. So essentially, closure-like syntax, kind of an easy way to do to write function objects that you can pass around to other places, and this lets us take our example we were looking at before, where we had a bunch of work we had to do, right? And we broke that up with a bunch of different kind of event callback-based approaches to life. In Grand Central Dispatch, we can take that block of code and turn that into something that we're just going to dispatch and have it run asynchronously. So very easy to get the global queue. You can also define your own queues, and we'll get to that in a little bit. And then say, I want to asynchronously perform this block of data. So the first thing we do is we go and we do the big long process. It's going to load data from the internet or whatever. And then we go and we say, I want to get my main queue to get back onto the main thread like we did before, and then go and show that data. So there's only 2 actual additional lines of code in this slide versus what we saw in our simple, the trivial kind of naive approach to this business logic. All we've done is added the async calls to route between the different Grand Central Dispatch queues. And this is an incredibly lightweight thing to do. Apple's put a lot of engineering into making this queuing mechanism be very fast and very lightweight, to the point where they actually recommend using this as a means to do data synchronization as well. So those of you coming from the C# world might have seen this pattern also, where you can perform work on a dispatcher and as long as all of your work is happening, as long as the dispatch queue is guaranteeing a FIFO ordering, you can actually perform unsynchronized shared data access just by using the dispatcher as your kind of shared data guard. So in this case here, we have some cache we need, and then we have a special queue that we've created, which is different than the main queue, just to separate out the queue characteristics and to allow us to tune that externally. And then we have some work that we want to do where we want to create a record and get that out of the cache. So we can dispatch async to our caching queue, and then pass in a block that will add this new record we've created to the cache. So this lets us populate the cache in a thread-safe way without using any locking at all. And of course, there's some locking happening somewhere in the stack with Grand Central Dispatch taking care of stuff. But by letting the dispatch queue do that work, we end up with a locking model that is actually compositional, rather than a synchronization model like we see in Java, which doesn't compose whatsoever. So this async stuff is great, right? It works well. Sometimes you need something to happen synchronously, though. Like sometimes I want to pull something out of cache, and I just need it. So what we do for that is there's a dispatch sync call, which will process through whatever else is happening in that FIFO. Because again, this cache queue is a FIFO queue that has a whole bunch of operations that might need to be performed, that somebody else asked for some async stuff to be tossed into it. So this dispatch sync thing might do more than just the work that you've asked it to, because it needs to flush out the queue before it can get to your work. But this lets us obtain a record synchronously from cache. Better to use the async stuff when possible, because again, anytime you're doing synchronous work on the iPhone, you run the risk of doing that on the UI thread and blocking the user. But assuming that you're already somehow backgrounding this process so that the user isn't impacted, dispatch sync can be an easy way to do a little bit more process-oriented or procedural-oriented code rather than event-oriented code for handling data. So kind of moving on from concurrency to the other big difference in the iOS development world, memory. The iPhone doesn't have garbage collector, so sorry about that. What you do, instead, there's a reference counting memory management approach to life. So it tends to be a little bit harder to get used to, but it's actually, there's a couple conventions that make it kind of disappear into the noise in the background once you get going with it. I expect to see a garbage collector on the iPhone soon. Now that they're heading towards multi-core CPU design for the newer iPhones and iPads, they can actually have background processors to do background work to garbage collect, so the pause issue won't be as big of a deal. Apple's come out and said garbage collection's the devil, you don't need it, et cetera, et cetera. The iPhone does not need it. Well, the Objective-C on the Mac has garbage collection, and Apple is well known for totally 180-degree position policy changes at the drop of a hat. So I expect to see garbage collection sometime soon. In fact, the new version, this link goes to a blog of some guy who identified a hidden flag in the new version of OS X's compiler that allows you to turn on heap compaction when doing a compile, and that's kind of a first step towards being able to actually effectively do garbage collection. So I wouldn't be surprised to see that soon. In the meantime, we reference count and we get notified of low memory conditions. So when the system says you're about to start running out of memory, you actually get a notification at the application level that lets you do work to clear up some space and to kind of do your own garbage collection, essentially. So the rules are pretty straightforward. When you allocate memory, you have a reference count of 1. So when we call alloc, we automatically have a reference count of 1. When you call retain, you add 1 to the reference count. When you call release, you decrement by 1. And when you call auto release, you decrement by 1 later. And later can mean a bunch of different things. You can actually define your own auto release pools and whatnot. So that can happen. If you're writing a particularly memory-intensive algorithm, you can actually define an auto release pool that will let you control when auto releases get processed. So the rules are retain. Oops, sorry about that. Retain what you need later. So if you're writing code that's going to need to access some variable later on, make sure you retain it. Release whatever you've allocated or retained when appropriate, when you don't need it anymore. And auto-release whatever you return from a method. So what that looks like is if we look at an interface declaration, this is what goes into the header files in an Objective-C class definition. We have an interface called person, which has a first name and a last name, string pointers. Right? So this is data that's going to need to be allocated and freed at some point. And then we have these property things. Properties basically let Objective-C automatically do the setters and getters and whatnot for us, so we don't need to create our own setters and getters. And we also have a message. We can send the full name message to this object to get, presumably the concatenation of the first name and the last name. So what that looks like in implementation code is we end up with the set first name method. Now this, you don't need to do this. I'm pulling this slide up as an example of how these rules are applied. But when you create an app property, setters you can then ask the Objective-C implementation to auto-generate a setter and a getter pair for you that deal with memory correctly. So there's this @synthesize thing that we can use to automatically create these things, and they get taken care of for you. You don't need to bother with it. But just to, for the sake of argument, if we wanted to implement this on our own, this is what's getting generated for you. Is something where the set first name method, what it does first is it retains the argument because it's going to need it later. So that's rule number 1. Then it releases the field that it has because it doesn't need it anymore. So that's rule number 2. And then it captures the argument that was passed in. And this ordering is important because when I invoke set first name here, this is a common bug that people will do when they're doing memory management on their own in Objective-C, where I've reversed these two methods, where I'm now releasing first name before I retain the passed-in argument. And this turns into a bug, because if I do this line of code up here where I'm setting the first name to that person's current first name, I'm actually going to see my memory count go to 0 right here, and then increment back up to 1, which means that this thing is now eligible for being destructed by the Objective-C runtime. So it's important to retain first and then release, rather than release first and then retain. And as long as you follow that pattern, then life is easy and memory management works well. The full name implementation then turns into something where we alloc a new string. And there's actually syntactic sugar to make this a little bit easier. But we alloc, and then we call init with a format, where we're passing in the format for %s. We pass in first name and last name as arguments to the format string. And then we return that string auto-released. So what we're doing here is, because this method does not need to hang on to this data, we therefore auto-release it as we send it back up to the calling code, because the calling code that way doesn't need to, it only needs to retain it if it needs to have a handle to it around. This means that this code will not be garbage collected when this block exits, but will be once the containing auto release pool scope exits, which in typical cases is once the current run loop is exited. So as long as you follow these rules of auto releasing stuff that you create, not stuff that someone else created, but just the things that you create, and kind of retaining and releasing in the right order, things are pretty easy. And then when it comes time to deallocate your object, you then release the resources that you've retained earlier on. So first name and last name, again, this happens automatically when you generate synthesized properties, but what's happening in the covers is we need to release that data. An interesting fact is nil, which is the Objective-C for null, is of type any. So you can send any selector to nil, and it won't fail. You won't get a null pointer exception. You'll never see a null pointer exception happening like that. So this code right here, even if first name and last name were never assigned to, that's fine. Any field that you might need to release, you just release it. And even if it's never assigned to, if you call release on nil, nothing happens. So kind of null pointer errors. The null checking is a lot less common in Objective-C code than what you'll see in Java and other languages, which is something of a mitigation of some of the annoyances of having to do this reference counting. Because on the one hand, we need to do our own reference counting, which is a bit of a pain. On the other hand, a lot of the kind of busy work around checking for nulls when you're cleaning things up and whatnot goes away. So kind of the yin with the yang. So in terms of memory management, looking through an example here, if I create a person object, again, I now have a retain count of 1 because I've allocated memory. And then I come down here and add the person to a list, some list, right? Well, that retain count for the person is now 2, because lists, when you add something to a list, the list implementation says, I need to hang on to this for later use. So it's gonna, because it needs it for its own internal data structures, it will increment the reference count. So at this point, we're done with the thing, right? Because all we're doing is adding this person to a list. We can then release our reference to it. We've allocated it, and now we're doing the release to clear out our reference. And now the reference count goes back down to 1. And then when some later piece of code deletes this person from the list, that's going to set the reference count back down to 0, because again, the list implementation, when you call remove, it knows, okay, well, I'm now removing this object from my data structure, so I'm going to release my reference count for the thing. And now we go to 0, and the next memory reclamation phase will call the dealloc method on person. So I mentioned also that we can also get notified when we're running out of memory. So the way we do that is just like with any other notifications we were looking at earlier. We just, when we define our application delegate, we register an observer for the memory warning notification, basically saying I'd like this selector to be sent to self whenever the system is running low on memory. And you can do this. You can do this at the application level or in your views. So you'll see people in the view controllers. If you have like on an iPad app where you have a pretty complicated view controller potentially, you can register at the view controller level something that will clear out memory for unneeded caches or what have you upon running low on memory. And all of those different callbacks will be invoked when that happens. And then in here, we just clear out some cache or whatever. Maybe we have a cache of a bunch of REST data that we can just go back to the internet to fetch if we need to. Well, if we're running low on memory, we can just drop that and help alleviate the memory pressure on the device. We also get calls whenever a view is loaded or unloaded. So if I switch from from the master view to a detail view, the view controller has an optional selector called view did unload that where we can then throw away our access to all those data structures for the view in memory, and then kind of propagate that on. That again helps alleviate memory pressure considerably. Sorry about that. We also need to basically after the Objective-C runtime calls this, it will call view did load again if the user hits back or something like that. So you get an opportunity to repopulate your your view if you need to. It's sometimes easier to store, to not bother with stuff on unload, but that just will help increase the memory pressure on your system if you do that. So by implementing this optional selector in your view controller classes, you're giving your application an opportunity to be more memory friendly at the cost of typically slower kind of back-forward response times when you're switching between different like master view controllers in the application. Because whenever if you do release a bunch of internal caches or things like that during view did unload, then you need to recreate that again when the user goes back to that page. So it's a bit of a trade-off. Moving on from the kind of the coding, how to code these applications and some of the techniques we use for that. Testing has been a disaster in the iOS world for the last 5 years, I guess, or 4 years now, and it just got a lot better. So Xcode has a pretty poor history, in my opinion, of dealing with testing. Originally you just couldn't. There was no integrated unit testing whatsoever. No integrated testing whatsoever, and then there was some some stuff that was added for supporting unit testing, but it could only run on the simulator. It couldn't run on the device. And when you're writing an iOS application, you do that using Xcode and a simulator, and then you periodically deploy the device to test it out and whatnot. The simulator is not perfect. There's a bunch of stuff it doesn't do. So you really want to test on device. And there was really no facility for this. So everyone went out and, or at least many of us went out and built our own little testing frameworks. I had a test harness that whenever my app launched on my devices, it would run through all the test code and make sure that tests were actually working. But the ability to do UI testing was limited because of some kind of just annoying implementation details for how the testing infrastructure were getting bootstrapped into classes. Well, it got a lot better in Xcode 4, which is the current release of Xcode. So now it's shipping with this thing called SendTest and OC Unit. If you want to learn more about OC Unit, Eric Donenberg is probably a really great resource for that. And it's in light years better than it was in Xcode 3 and before. So it's a real big step forward. And when I say this, it's embarrassing, but one of the things they added, now you can have it. You can do debugger stepping in a unit test. It used to be you couldn't do that. It used to be there was no. You could either run a unit test or use a debugger, and you couldn't do both. So when I say it's light years better, it's still no XUnit from the enterprise world. But it is getting to the point where it's considerably better. Another alternate is GHUnit, which kind of evolved out of a bunch of code that Google wrote for building their internal iOS applications, and it's quite popular in Xcode 3 and prior. It's kind of the only solution. It's the only game in town. It's a pain to configure and set up, but it's the least amount of pain of all the different things out there. And in Xcode 4. It's a little harder to say which one to go with. Apple has been known to add testing features and then remove them in later releases. So it's worth keeping an eye on GHUnit, even to the extent that you want to use SendTest as a primary kind of integrated story for testing. Also, one other thing to note is I mentioned Xcode 4 a few times. Well, it's a lot slower than Xcode 3. Xcode 3 is a really, really fast IDE designed kind of, it's a C code editor that has some IDE features on top of it. Xcode 4 does a lot of really cool new static analysis features and a lot of great new refactorings and things like that, but on slower hardware, older hardware, it is slower. On fast hardware, on new stuff, you should be using Xcode 4, but like on this machine, this is a 3.5-year-old computer. It works well for me because I'm running an SSD and I have 4 gigs of RAM in there. But if this was like the spec version of this computer with 2 gigs of RAM and a spindle, I probably would still be using Xcode 3. So it's not Xcode 4. While it's the new way forward, it's not yet the. You will still see teams out there using Xcode 3 rightly. But yeah, the good news is way better than it used to be. So I'm thrilled about where they're going with testing, and it seems like they care about it all of a sudden, which is a big step forward. You can automate SendTest for automated builds. You actually can automate GHUnit, but it's a bit of a exercise in frustration. On Automating send test is considerably easier, so you can end up with phones plugged into like a Mac Mini or something like that as part of your build server environment that will run automated tests on device, which is a big advance. And finally, the App Store is, as I'm sure you guys are all familiar with, it's a walled garden, and it works great as a distribution mechanism, but the approval latency is really unpredictable. So you submit an app to be approved, and at some point in the future, you'll get an approval or a rejection. But you have very little insight into where your app is in the process, very little insight into when it will be approved or when it will be approved or rejected, either way. You kind of just, maybe it'll be 3 days until approval, maybe it'll be 6 weeks until approval. And they've been getting better at this, but it's very hard to get good insight into what's going on from a scheduling standpoint, which is really frustrating if you're in a fast dev cycle. We do client pushes to our C# code once a week, auto updates to our C# code once a week, and we do server updates once a day, once every 2 days or something like that. And so iPhone development is the long pole. iPhone release cycles are the long pole in our build and test environment, which is kind of ridiculous. I mean, it's you'd expect that to. It shouldn't be that way. It should not be that hard. Which is actually a compelling case in a small team that's a very agile team for using the kind of going, even when delivering an iOS application, going the web app approach to the world rather than going the full client native approach to the world. This is definitely, I don't think it should be a factor in the decision-making process, but Apple has essentially made that a decision-making factor. Is you're signing up for an external party being involved in how long it's going to take to get a bug fix or a hot patch or something like that out to a customer. So a little bit something to be wary of. That's not particularly. It's different in the Android world. You have different App Store problems in the Android world, but not necessarily better problems. Beta distribution is a pretty interesting. I've seen a few people deploy applications as betas because they were targeting a small enough audience that they were okay with just having a limited number of users they could deploy to. And when doing a beta deployment, you don't need to deal with the App Store. You're doing that kind of outside the App Store. You can just ship somebody an application and they can install it on their phone directly. So it's actually, the number of applications where that's an acceptable, where the kind of the beta limits that Apple imposes on the number of devices you can share with are acceptable is pretty low. But for some kind of enterprise sorts of applications, this is an acceptable way to go. The other thing you can do in an enterprise, you actually get an enterprise license that for iPhone development that will let you deploy to an organization kind of centrally, rather than requiring your organizational users to go through the App Store. This is kind of the distribute a beta approach is kind of the cheap hack to getting around having to pay for that more expensive approach. And take a look at TestFlight, which is a neat website and app for making it really easy to send out betas to a large group of people and to manage the beta process and things like that. It's a cool little service that we've been evaluating for our iOS work. And I'm going to cut that off there because we're running out of time. If you guys have any questions, I can take 2 or 3 questions now, and then I'll be around today and tomorrow to answer other questions you might have. So, anyone? Questions? Yep.
In your previous code examples, it appeared that you were mixing kind of old C-style method calls and this Objective-C approach, right? You call through the Grand Central Dispatcher. Is that the way it was, or am I misunderstanding?
No, that's the way it was. That's the way it is. The question was, there's some mix of old C-style stuff and Objective-C code calling in the slides I was showing. There is a mix of C code and Objective-C code. So Objective-C is a superset of C. So a fair bit of things are implemented as C calls. So you will definitely be making direct C calls. For example, all the reflection stuff. Whenever you want to reflect to look at an object, that's all C. which not because it has to be, right? I mean, they could have written an Objective-C wrapper on top of that, but there actually is a certain footprint of heterogeneity between C code, C implementations, and Objective-C stuff on top of that. So definitely kind of, it's not a language built on top of C, it's a language built extending C. So you will see both. Anything else? Cool. Thanks, guys.